Hello everyone, welcome on our presentation. The topic we would like to raise today is managing big data projects in a constantly changing environment. The presentation will be held by my colleague Rafał Małanij and myself. My name is Rafał Zalewski. I'm a senior project manager in Getting Data. I have over 12 years experience in IT project management and software development. Generally, I'm leading the teams focusing on delivering a solution to the customer using the appropriate business measurement and terms and conditions for the project. I manage full cycle of the project from the initiation phase through planning, analysis, development, tests, UATs to the production deployment. I'm responsible for cost estimations, project scope, deliverables, tasks, and I provide day-to-day direction to the project team and regular project status to the customer. I have a technical background and I'm holding many certificates from project management area like Agile Project Management Practitioner, Professional Scrum Master, Professional Scrum Product Owner, Prince2, ITIL 4, and I'm also having a technical certificate from Cloud Infrastructure, AWS Solutions Architect Associate.
Hello, my name is Rafał Małanij and I've been into IT for over 13 years. Starting as a service management person, then project management. Right now I'm holding more business focused positions in Getting Data. My areas of interest are cloud native, DevOps, data science, and big data in general, and also genomics. You can know me from some of the initiatives that are happening in Warsaw or used to be happening before COVID, like PyData Warsaw, Data Science Summit, and a couple of other conferences. So over 10 years ago, when I was working in an organization supporting one of the largest corporate data warehouses in the world, I was involved at the time in a project that was about to remove one of the data sources from the reporting, and it was supposed to happen at a certain date. That was literally one line of metadata that was updated, and over 3 months of testing, if the reports are correct, if there's no impact on any other reporting, on downstream systems, if it works with a cutoff date. We're testing this one line of code for weeks together with business users. My friends doing regular software development would not believe me it was true. Why it is like that? Because data analytics projects are not just software development projects. During past decade, they were even more about data than software, with these fancy user interfaces and drag and drop ETL tools. Fortunately, with clouds and with cloud native and everything as a code paradigm, we're closer to software engineering, but still the focus remains on data. And actually, from business perspective, this is what counts. This is what brings the value. The insights we might get from data, not the software, nor the platform itself. In software development project, we just put into code the business functionalities we already know. We automate our work, but we more or less know what we're doing. It is a more question of how we define what we want to do than finding out what we want to do, which is not a simple task, of course, as you can see on the slide, when business analyst is trying to explain to a developer and to the guys in the team how the functionality should look like. This medical business value is kind of ephemeral. We know there's something, and once we nail it, we prove it works. We're going to hit the jackpot and improve our KPIs and make our business happy. This is actually our goal as data analytics teams or big data project teams. Make a business happy and make their life easier. But it's not like we know from the very beginning what results we could expect. Obviously, we could copy paste some ideas from the market, but there's always some uncertainty. How it's going to look in our company, how it's going to look in our environment. If we do something novel, the bid is higher and it goes up in parallel with the possibility of failure. It makes big data project more like a research projects than implementation projects. You start with an idea on what you could achieve with data. You formulate research question, find data you could use, and maybe acquire some data, maybe produce some data somehow. You define hypothesis, then design methodology, and obviously at the end, the way you could measure that and measure the impact of this analysis on the business. Once you want it to be a repetitive operation or run your experiment in a more structured manner, so you don't have to invent the wheel every time you're doing another experiment, you might need a kind of a big data platform to run it there. And there you go. You have your big data project. Looks completely different compared to software development, more like a plan for a PhD thesis than software engineering. You have completely different starting point. A research question instead of business processes like in typical software. Over the time, data products got more complex as well. The days when you had that one data source, couple data sources, ETL tool, database, and a BI tool on the top of that are actually gone. If your project has something around machine learning, what is rather the standard right now, areas that you need to cover would probably look like this, like on the slide. Actually, this diagram shows the amount of machine learning modeling in the whole process. And as you can see, it's just a tiny bit of the whole process of creating and deploying machine learning model in production. This means more roles and more people are involved in the project. What is more, people from different worlds, from software development on one hand, and from data science from the other. They sometimes even do not speak the same language. And I'm not talking about like language barriers here. Some time ago, I was talking to one of the analytics managers in one of the companies, and he told me that his biggest problem is that his data scientists don't have experience in software engineering. So they're like self-made engineers, I would say, more focused on data science. And his developers have not much idea on how data analysis looks like. They have some ideas, but not very in details. In a successful project, you have to actually make both ends meet and communicate effectively between each other. Technology itself does not help either. Although big data is just a few years behind the software engineering and cloud native basically, it is speeding up, and the number of available technologies is growing rapidly. The number of moving parts is in every big data platform is growing, and the speed of development is actually amazing. Look at the slide, and you can see an extract from Matt Dusk's Data and AI Landscape from 2019-2020, just an orchestration on management or pipelines part. As you can see, there are not only more technologies, but there are like different technologies and different functionalities covered with this part. So it's not about the number of tools available only, but also the evolution of functionalities of these technologies. So it is not like in the old days that you design platform and you keep using this architecture for like 5 or 7 years. If you think you're going to design best architecture from day one, you have wrong assumption. Be prepared to change your building blocks much more frequently due to different reasons: new requirements, new technologies, some other requirements or some other constraints. Public clouds helps a bit as there is someone else who's actually managing this software stack for you, but you still have thousands of blocks you need to use to build an end-to-end platform. So how to structure this kind of projects? Imagine you're starting a big data initiative in your organization and you need to convince your top management to approve it and fund it. You need your CEO approval, and you need your CFO to give some money on that. It is not a typical business case where you define resources, timeline, and get more or less predictable outcome. In big data projects, you cannot really predict the outcome. It can be a failure. In the case of big data, it is more like a journey to become a data-driven. The decision is on a strategic level if you want to follow it or not. Your leadership team has to decide on that. But like everyone is doing something around data, and it might be easier to just point out how your competitors are working with data, so to make them more convinced. And then it's all about the money. You have a vision on how to do analytics, but there's a need to bind this to time, money, and outcome triangle. Big data is about innovation. So why not to structure it as a learning problem? Test an idea, learn, test another one, and so on, so on. Always start with the use case, define research question, and with help of proof concepts, minimum viable products, prove the actual value that you bring to the organization with this project. It is sometimes called a proof of value. So why not take the smallest and simplified amount of work that you can take care of and make a bet it will meet the objectives. If you win, you can take another small step and learn in between. Probably you're going to change directions a couple of times because it is about taking small risks, failing, learning, taking another bet until you reach your actual goal. And the goal is more like a moving target. So it's more about the process of implementing the big data in the organization. And I have seen a couple of Polish companies that were about to take another step in their big data or analytics journey. They're obviously asking all around about ideas, employing consultancies to tell them what to do, having endless meetings about directions, priorities, concerns, risks, spending months on that, bearing costs, and actually bearing another lost opportunity cost. The problem was that they were not actually learning anything. So they're bearing costs, spending time, and not much learning on these activities. They were so afraid to fail, so they were paralyzed to make another step. Instead of spending this time on debates, they should actually be more open failures, taking risk and actually doing something, running POCs, experimenting, actually learning. Henry Mintzberg's emergence strategy model might be helpful in this case. The idea behind this model is that you have some ideas, some vision, but it should not be carved out of the rock. There are always unrealized strategies and opportunities that arise in the way. So you need a space, or first of all, you need to have a way to get rid of some strategies that are not working anymore or might not work anymore, and you need a space to involve new ones that are arising on the way. So when it comes to business case, short next few experiments you want to run, what are you going to learn out of it, and how it aligns with the broader picture.
As my colleague has mentioned, when you start your big data project as a project manager, you will very quickly learn that the environment is much different comparing to the environment of the software development projects. You will face a bit new reality where you as a project manager need to find yourself in. And the first item that you will definitely notice is that the big data project is less understood by the clients. I mean, software development projects are a bit more friendly. I mean, if you start a project where the outcome is a mobile application, web application, or maybe the extension of the current system, and the company is highly likely more familiar with the look of the mobile apps, the websites, the system designs. It's usually not that case in big data projects. It's highly likely that the client has little knowledge about available software or architecture. I mean, it's all right, it's understandable, as big data solutions are still quite new in the market, and many companies are still introducing themselves into this area. And so your role as a project manager in this scenario is to help clients. And how can you do that? Quite obvious in big data, but not necessarily in software development. Just don't forget to include trainings in your project scope. I mean, I would advise even to record the trainings and then publish the recordings to the client in the form of creating a knowledge base. They will definitely go back to these recordings and watch them again. This approach will firstly confirm that confirm to the client that you have necessary knowledge for the project, and also build trust and relations. It will also create open environment where questions are welcome and client gets the right knowledge. Once they understand the architecture and the approach, next step is to work with the client on the real data. And I can say from my experience that it's quite easy to find some small examples to the MVPs. The client highly likely has some ideas or visions, what they would like to know more about their data. So try to extract some small scope from this proposed MVP and work with the clients on building it. I can definitely say that once client sees their own data analyzed in the right way, they will gain trust to your solution, and they will open a big bucket of new ideas to work on. Don't forget to work closely with the client analysts. After all, the big data is about the data, so the quality of the input is absolutely necessary to get the right output. And also I can say from my experience that sometimes you can receive by mistake a wrong data or not complete one. Therefore, all your analysis might bring wrong and provide wrong results. That is why it is very important to work closely with client analysts, understand the business processes, and verify you understand them correctly. So the right input can give you right output, but wrong input will give you surely wrong output. Let's see some other risks that are more technical, specific for the big data. First one is unorganized data. I mean, you need to realize that the client's data comes from a number of sources and in number of forms. And there is structured data, there is unstructured data, there is the data coming from online or offline sources. And all of this data keeps piling up each day and each minute. And it is overwhelming for companies to manage such unorganized data sets effectively. So the solution here is well-planned governance strategy. And you can ask, do we really have so much data? I mean, so let me mention that here, the recently increasing source of the data is, for example, Internet of Things. And the predictions of the amount of connected devices are quite crazy and counts in like tens of billions. I even read that there were estimations of 50 billion connected devices for just 2020. And there is another 35 billion devices will be installed by the end of 2021. And you all know that for individuals, there are numerous consumer devices which work out of the box. We all know some like indoor lighting, outside temperature sensors, cameras, motion sensors, some automatic locks, some other control devices which can be integrated into security and monitoring systems. There is even some water leak sensors, smoke alarms, dryers, and even refrigerators. So it's strongly advisable to plan governance strategy on how to maintain the data. If you decide for a bigger changes later in the project timeline, that might be quite noticeable change request for your project scope and the budget. The next one is the data storage and retention. And this one is also obvious risk associated with big data. When data gets accumulated at such rapid speed and in such huge volumes, the first concern is its storage. And traditional data storage methods and technology are just not enough to store big data and retain it well. And so enterprises today need a shift to cloud-based data storage solution to store, archive, and access big data effectively. So definitely moving to cloud is the right approach. Next one is cost management. The process of storing, archiving, analyzing, reporting, managing big data involves cost. Many small and medium enterprises think that big data is only for big businesses and they cannot afford it. However, I think that with a careful budgeting and planning of resources, big data costs can be reduced, especially when there are more and more managed services in the cloud available where you pay for the usage only. And let's not forget that big data projects have some planned return on investment and therefore acts as a revenue generator. Next one is incompetent analytics. Well, I mentioned that a bit before, but without proper analytics, big data is just a pile of data lying in your organization. So analytics is what makes data meaningful, giving management valuable insights to make business decisions and plan strategies for growth. So with data growing at such an amazing speed, there is obviously a lack of skilled professionals to analyze big data efficiently. It exposes enterprises to the risk of misinterpretation of data and wrong decision making. So hiring right talent and applying the right tools is crucial to make relevant decisions from a big data project. The next one is data privacy. With big data, obviously, comes the big risk of data privacy. Enterprises make use of sensitive data, personal customer information, and strategic documents. When there is so much confidential data around, the last thing you want is a data breach at your enterprise. So a security incident can not only affect critical data and bring down your reputation, it also leads to legal actions and heavy penalties. So taking measures for data privacy is not just a good initiative anymore. It's a compliance necessity. Considering this risk I mentioned, what is my recommendation when it comes to the project management for a big data project? Well, my recommendation is go with Agile. It seems to be a very natural choice. If we look the project requirements, like close collaboration between the client and the project team, or the scope can be dynamic and changed. So just be open for a change. Or we can refine and reprioritize the product backlog. Or the project is broken down into smaller units. So we work in small iterations where we have better control, but at the same time, flexibility for the future direction. All of this directs us into Agile. And from my experience, I can say that Scrum framework works here very well. In all of the Getting Data projects I have managed, we have followed all the Scrum events. So we start from regular planning meetings with client to make sure both parties understand the scope of the sprint, the data, and the planned infrastructure. We kept daily meetings where developers think with each other. And on sprint review, we show the progress of work. And on sprint retrospective, we discussed what we can improve in next sprint. Thanks to this approach, we achieved large transparency in front of the client, about all of our work. We achieved better relations with clients as they were getting more and more familiar about the big data field. We provide not only a working solution, but also great trainings for the clients. So they created a base of knowledge and understand better their final outcome. And we made sure that the final product provides best return on investment for the client. And it's usually even better than initially expected. So I strongly recommend that approach. Thinking ahead, this way also even helps to open a new projects for the future. As the relations are established, the trust is gained, and more clients knows about the final product, the more ideas come with how to extend it.
Okay, thank you so much for attending our talk. I hope you enjoyed sharing our practical experience in planning, managing big data projects.